Hello everyone, I'm Sam, responsible for frontline service and technical training for equipment maintenance at Lichili Intelligence. Welcome to episode 5 of series 2. Last time we covered the addressing system. Remember, the stacker knows where a location is thanks to addressing. But you might ask, is knowing the position enough? Not quite. Whether the fork reaches in squarely and pulls the load out smoothly is the fork's job. The telescopic fork is one of the stacker's most precise actuators, and also one of its most failure-prone parts. So this episode systematically covers fork maintenance and centering adjustment. 4 learning goals today. First, understand fork types and structure. You need to know what it looks like first. Second, learn centering. In plain terms, making the fork extend level and straight. Third, master chain tension synchronization, which is critical. Fourth, learn to troubleshoot common fork faults. Get these down, and your pick's put success rate rises sharply. There are 3 main fork types. The single deep fork is the most common, 1 location per cycle. The double deep fork reaches 2 locations deep and is more efficient. A multi-fork is used in high-density stores. Note that whatever the type, the core components are the same. The fixed fork mounts on the load carrier, the middle fork is chain-driven to slide, and the top fork contacts the pallet directly. So the chain drive must keep both arms extending in sync. That's the key to centering accuracy. And the condition of the guide rollers directly affects how smoothly the fork moves. Fork accuracy requirements are very specific. Note these 6 key metrics. For example, arm levelness period 2 mm per meter. The fork must be level when extended, not high on one end. Parallelism port at 5 mm over the full length. The 2 arms must stay parallel, not toe in or toe out. And one that's easily overlooked. Sync deviation, within peers millimeters, meaning both arms must extend to the same length. So what happens if these are out of spec? At best, the pallet jams in the location. At worst, the fork strikes a rack upright and causes serious damage. So I recommend checking once a month. Now, leveling measurement. In 4 steps. First, move the stacker to the service position. Lower the carrier to a convenient height, and fully extend the fork. Then place an electronic level on the arm's top face and measure at the root, middle, and tip. If it's out of spec, adjust. The most common method is shimming ballers, shim, whichever side is low. Remember the key points. Add 0.5 mm at a time, up to 3 shims, and always remeasure to verify. The rule of thumb: shim the low side, go small and remeasure after each step. For parallelism, we take one arm as the datum and measure the gap between the 2 arms at the root, middle, and tip. The difference between the spec gap and the actual gap is the parallelism deviation. There are several adjustment methods via the side rail slots, via lateral movement at the mount, and fine-tuning via the guide roller's eccentric shaft. Note how clever the eccentric design is, or turning the shaft moves the roller and so changes the arm gap. The diagnosis is simple: too wide a gap means toe out, so narrow the rollers. Too small means toe in, so widen them. Chain synchronization is the most critical step in fork adjustment. The principle: each side of the fork has a chain driven by the same motor, but if the 2 tensions differ, one side moves faster than the other on extensions, skewing the arms. The method: fully extend the fork and mark both arm tips. Then retract to mid-stroke and measure the offset between the marks. Find the chain tension adjusters and turn a quarter turn at a time. Loosen one side, tighten the other, re-extend and measure again until the sync deviation is within 2 mm. Keep both tensions equal. Neither too tight nor too loose. Now, the limit sensors. The fork has several. For instance, the fully retracted limit triggers when the fork is fully drawn in, telling the stacker it may travel. The fully extended limit triggers when fully out, allowing the lift to pick or put. There are also load detect and anti-collision sensors. To calibrate, loosen the sensor's mounting bolt, hand move the fork to the target position, then slide the sensor to where it just triggers and tighten. A proximity switch usually senses at 2 to 5 mm to alert. Too close risks impact damage, too far means no detection. And always run a few cycles by hand to verify after calibration. Fork daily maintenance has 4 areas. First, lubrication, chain monthly, rails and slots monthly, roller bearings quarterly. Second, fasteners, retorque the arm mounting bolts monthly. Note that an M16 bolt is typically 200 Nm. Third, wear checks, rollers, arm surfaces and sprockets, all on a regular cycle. Fourth, accuracy rechecks, levelness, parallelism and chain sync every month. When a common fault appears, don't panic for noise or sticking. Look at the rollers first. For uneven speed, check chain sync. For a skewed pallet, measure levelness and parallelism. This page is a quick troubleshooting guide for the fork. Don't panic at a fault. Observe the symptom before locating it. For example, if the fork won't move, check the safety devices and power first. For noise or sticking, look at the rollers and lubrication. For arms out of sync, it's most likely a chain problem. For a skewed pallet, measure levelness and parallelism. Remember 4 points. Observe before touching. Work left to right, outside in. Let measured data decide. And always verify with cycles after a swap. One figure to remember, 70% of fork faults can be prevented by disciplined daily maintenance. This page is the complete SOP for fork centering, in 7 steps. Step 1. Prepare, tower off. Gather tools. Clean the surfaces. Step 2. Measure level. At root, middle and tip on each arm. Step 3. Adjust level. Shim the low side, 0.5 mm at a time. Step 4. Measure parallelism, width difference at matching points. Step 5. Adjust parallelism. Turn the guide roller eccentric bolt. Step 6. Chain sync. Set the tensioners so both chains are equal. Step 7. Test run. 3 cycles plus 3 picks put tests. Each step has a clear method. Follow them in order, and you won't go wrong. This page is the complete maintenance schedule for the fork, from daily to annual. What each cycle needs is at a glance. Daily, listen to it run. Weekly, eyeball the chain. Monthly, measure levelness, parallelism and chain sync. Quarterly, check rollers and limit sensors. Semi-annually, deep clean. Annually, a full overhaul. The way marks the cycles where accuracy rechecks are the focus. Print this table and post it by the panel, ticking off each task so nothing is missed. Here's a real case. At one warehouse, the stacker kept dropping pallets on retrieval 2 or 3 times a week. Operators said the right arm lagged the left by half a beat. After a long search, the right chain turned out to be slack. Its tension spring had fatigued. Worse, because the chain had been slack for so long, the sprocket teeth were also worn. Slack chain wore the sprocket. The worn sprocket let the chain go slacker. Still a vicious cycle. Only replacing both chains and both sprockets fixed it. The lesson: don't judge a chain by its surface tension. Measure the fork's actual sync deviation on extension. Let's recap today's key points. Memorize the 6 accuracy metrics: levelness, parallelism, straightness, stroke, sync, deviation and height difference, each with a clear tolerance. The 3 most important things: remeasure levelness, parallelism, and chain sync every month. Chain sync is the core of the core. The core why? Because unequal chain tension skews the fork and the pallet slides off. Limit sensors are the safety floor F7 and always verify after calibrating. Finally, remember the troubleshooting order: rollers first, then chain sync, then levelness, and parallelism, and sensors last. That's it for today. We covered fork types and structure, the 6 accuracy metrics, measuring and adjusting levelness and parallelism, chain synchronization, limit sensor calibration, daily maintenance and troubleshooting. Next episode we enter a new area, the shuttle, or RGV. The RGV handles horizontal transport in the AS/RS, and its failure modes are quite different from the stackers. Stay tuned. And at the end of the course, Let me introduce our core business. The Le Chili Vietnam team specializes in providing logistics, automation, equipment maintenance, and repair services for local Vietnamese enterprises. We have a dedicated local service team, which is much more efficient than remote coordination. If you need help, feel free to contact us for consultation.